FL Smith is the world's leading supplier of equipment to the cement industry. One of the machines in FL Smith's comprehensive range is the ATOX vertical mill, which combines the drying, grinding and separation processes in a single compact unit. A unique feature of the ATOX mill is its floating three-roller grinding system, which offers many benefits in terms of efficiency and compactness. FL Smith's policy is, whenever possible, to source a significant proportion of components in the customer market. But the mill's vital components are manufactured here, at FL Smith's Copenhagen plant, where there is close liaison with the design engineers. The ATOX mill must give decades of reliable operation, and there are no compromises in terms of the materials selected. The grinding table is of nodular cast iron. Its rigid design and precise machining ensure perfect support for the wear segments. Precision machining is, of course, also essential for the hot-forged roller shafts. The tension rods, also hot-forged and made from a special high-strength alloy steel, are one of the key features of the ATOX mill. They apply a downward load on the rollers, thereby providing the grinding force. In the latest generation of ATOX mills, both the tension rods and the horizontal torque rods, which keep the roller assembly firmly positioned, have been redesigned to ensure maximum efficiency and years of trouble-free service. There are quality checks throughout the production process, and detailed final inspection of all components ensures that every ATOX mill will operate at its designed level of performance. Basing the concept on its many years of experience in the manufacture of Symetro gear units, FL Smith has, for the past 15 years, produced a gear unit specially designed for the ATOX mill. The unit has a power range of up to 4,000 kilowatts. It is a conventional right-angle gear unit with one spiral bevel and two helical stages. To take up the heavy loads from the ATOX mill, the flange on which the grinding table is placed is supported by a semi-hydrostatic thrust bearing. The bearing shoes, leveled to a tolerance of plus or minus 15 microns, transmit the vertical load from the mill through the very rigid gear casing to the foundation. The shoes are tiltable, and with this large carrying surface, the bearing is able to run hydrodynamically. Cooled, low-pressure oil is supplied at the oil inlet zones between the thrust pads. Each bearing shoe is also provided with a pressure pocket, through which high-pressure oil is supplied, giving the thrust bearing its hydrostatic effect. Both the low and high-pressure lubrication systems are filtered with 10-micron filter elements, integrated with the oil supply unit. The teeth are precision cut, and the bevel gear and helical pinions are case hardened and ground. The helical gear wheel's teeth are through hardened. Ample dimensioning ensures a high service factor, with perfect meshing ensured by distance rings and eccentric bushings. With an efficiency of more than 97%, it is easy to turn the gear unit manually. Efficient lubrication of all teeth meshings and the unit's bearings ensures perfect oil films and transports heat away from the pressure zones. Accessibility is an important feature of the ATOX gear unit's design. There's ample space for maintenance, and visual checking of the condition of the gearings and the lubrication system is easy. One of the more recent installations of an ATOX mill was in late 1992, at the Iberia cement works south of Madrid in Spain. A 180 tons per hour raw meal mill was required for a new line, and the compact design of the ATOX mill made it ideal for the rather constricted location. At this stage of installation, the foundation for the mill had been prepared by a local contractor, and the drive unit and grinding table were in place. The next step is to position and secure the rollers. Fitting the rollers is a rapid and relatively simple process, carried out under F.L. Smith's supervision by a local crew. Simplified and precision assembly is ensured by the use of special hydraulic tensioning tools supplied by F.L. Smith. These are also used subsequently during maintenance operations. The design concept: a 3-roller unit attached to a central yoke that only allows vertical movement. Here again is the drawing shown in the introduction, so that the various main components of the mill can be identified. At the top, the high-efficiency, third-generation separator unit, dividing fine particles from the coarser particles which must be returned to the table for further grinding. A 60 meters per second air draft dries the ground material and carries it upwards from the nozzle ring, removing the finer particles from the grinding bed. The raw material is fed in at the side between 2 of the rollers. The rate of feed is controlled by measuring the differential pressure across the mill. The rollers are held firmly in position on the grinding bed by the central 3-point yoke and horizontal torque rods attached to the outer ends of the roller shafts. The wear segments on the rollers and grinding table are offset to ensure minimum vibration. Downward pressure is applied to the rollers by the 3 vertical tension rods, also attached at one end to the roller shafts and, at the other, connected to hydraulic cylinders at the base of the mill. Here, the transmission of forces on the rollers through the vertical tension rods, rollers, grinding table and gear unit is shown by dotted lines. The segmentation of the wear parts bolted to the rollers and grinding table are a special feature of the ATOX mill. The segments can be replaced quickly and easily, and the roller segments can be reversed to prolong their life if wear is uneven. Once the rollers are in place on the grinding table, the next stage of assembly is to attach the torque rods and tension rods to the roller shafts. The beam that can be seen here is a standard ATOX mill feature. Although replacement of wear materials and other normal maintenance can be undertaken while the rollers are in place, the beam enables them to be removed for overhaul if necessary. In the final stage of installation, the separator unit is assembled on the ground before being positioned and secured in place on top of the mill. The separator is often fabricated locally, before assembly on site under the supervision of an F.L. Smith engineer. The separator's intermediate section is lowered into place, and the louvers are mounted. The separator unit is now lifted into position and fixed to the top casing of the mill. Assembly is in 2 stages. First, the separator's flange is bolted to the flange on the mill casing to ensure a distortion-free, airtight fit. The separator casing is then welded to its flange. The mill is now almost ready. All that remains are a few details, such as fitting the access door to the mill casing. Then there are the final adjustments. One of these is the precise positioning of the rotor inside the separator unit. It's important that the clearance between the rotor and the top of the separator housing is as small as possible to prevent blow-through. The mill is now ready for its first test run. The control systems have been installed for the hydraulics and the lubrication system. The various PLCs can be operated either locally or from the cement plant's central control room. Before the main motor cuts in, the ATOX Mill's hydraulics system lifts the rollers, greatly reducing start-up vibration and eliminating the need for a barring device. After the main motor has started, the feed system is also activated. The rollers are lowered onto the raw material, and the tension rods apply the grinding force to the material bed. In the control room, the operator can now check that the mill is working as it should. The monitor shows that all is well. The depth of the grinding bed is being maintained at around 50 millimeters. Design improvements based on many years of operating experience ensure that the new generation of ATOX mills is second to none in terms of efficiency, reliability and ease of maintenance. A compact design, combining drying, grinding and separation in one unit. The very large diameter of the rollers means that the ATOX mill can handle very coarse feed without the need for fine pre-crushing. Strictly parallel movement ensures high utilization of the wear material on both rollers and table. Segmentation of the wear material permits increased thickness and use of the hardest possible material without fear of cracks developing. The roller segments can be reversed to further extend their life, and segmentation also permits the easy replacement of wear parts within the mill housing. A newly designed rotary sluice simplifies the handling of very sticky materials without clotting and reduces the amount of false air. The rotary separator is also a new, highly efficient design which gives a substantial gain in production capacity. And the rated capacity of the ATOX mill compares favourably with the capacities of other mills with equivalent table diameters. The wider capacity margin means a stronger, longer-lasting mill at the rated output. Taken together, all these advantages add up to a highly competitive mill in terms of both capital investment and operating cost. The ATOX Mill from F.L. Smith.